So today's topic is we are going to discuss about Iceberg. What is Iceberg and where it comes into picture into the big data world, right? So generally, like when we talk about Iceberg, right, it's just a table format. So we have multiple things in Hadoop, right? If we talk about Hadoop, it started way back in 2008, where we had Hadoop 1. It's based on the GFS file system, right? So everyone knows the history. So we had name node, data nodes, then we had yarn, then we had MR1, it moved to yarn. So always Hadoop used to transition itself. So now, so basically this is something like we already have file formats, we have blogs, splits, data and everything. What is the need of Iceberg? So that's the main question, right? We already have multiple things. So what is the need of Iceberg? So basically, as I said, Iceberg is a table format. Where it fits in itself is like we have multiple issues in the big data world over the time the data has been grown. So initially, if you see like we had very few node clusters with minimal of data. But currently, if you see there are 1,000 node clusters with petabytes of data, the data has grown enormously and we had multiple bottlenecks. If we talk about bottlenecks, right, we have bottlenecks with name node, we have bottleneck with HMS, it's a Hive Metastore server or the backend database. So to overcome all of this, right, so we have, so basically to give a bit history of Iceberg, it has been introduced by Netflix. So Netflix started this project around in 2015. So the need for Iceberg for Netflix is like, so everything comes based on a problem, right? The problem they faced is like they had huge data sets. They are moving their data from on-prem to cloud. When they were moving the data from on-prem to cloud, they faced multiple issues when moving the data from on-prem to cloud as a storage, right? So when Netflix moves a solution from on-prem to a data warehouse solution, they started to face multiple issues when they started using the system, the consistency of data. Then sometimes it gives false data. For if someone queries the data, it gives inconsistent data for others. So to solve all this problem, they have started this Iceberg as a solution, and they have contributed Iceberg to the community in 2018 November. So this is a general big data system looks in current day, right? We have multiple challenges, as I was saying, right? We have multiple ways to ingest data into Hadoop. So we have multiple ways, which means like initially we had a data warehousing, we had Hadoop as a solution. Yeah, initially we had Hadoop as a solution for only solving the traditional data warehousing solution, right? But wherein we had multiple types of data. We had structured, unstructured, semi-structured data, but we also started getting data from IoT and other devices. So there are multiple form factors of data which is getting into environment. Basically, we used to pull the data using API or many mechanisms, right? Then we used to get the data to a staging environment, and then we do some cleansing, and then we push it to data warehouse, and it is consumed by multiple teams, and it is pushed into a BI tool. So this is our normal structure looks. But the problem here is we have multiple silos. So which means like we'll have multiple data sitting on multiple places. Say, for example, if you want to give a same data to two different teams, maybe you'll have a dev DB and a prod DB with same data repeating it two places, and you will be giving it. So we not have a unified solution with this model, and we have a couple of other problems as well. So basically, Iceberg eliminates these silos and multiple copies of data. As I was saying, you have same data repeated in 2 DBs. As an example, I said, since we don't have versioning in Hive tables, right? So these are some of the internal terms which is used in CDB public cloud. So this data flow is NiFi, and we have Flink as a service, that's CDF. And we have some data warehouse solution that is CDW. And we also have CDE, that's a Spark engine, which runs with Airflow. So these experience runs as a data service. It runs on Kubernetes. So it's a public cloud offering. We also have data services in private cloud. So that interacts with Iceberg. Then Iceberg communicates with your data warehouse and machine learning, and it's consumed by the end users ideally. Then you'll go with your ETL and transformation of the data. So these are the key challenges, right? Say like you have a table of 10,000 partition with multiple data set, say like 1 lakh objects you have given a table, right? When you run a query against a table, so one of the problem, I'll take an example from Netflix itself because they have contributed it. So they had a table with some 2000 or 3000 partitions, but it had a large number of files. So basically, what they found is like the query, whenever we submit a query, we know the flow, right? Basically, it gets into HS2, then it goes to compilation, then it comes to execution. So basically, the query was spending 12 minutes in compilation itself. So the reason being, so it was handling huge number of file objects. So that's one of the bottleneck they faced in Netflix for the query planning with respect to the regular legacy model of tables. Then scale. So we all know, as I said, like Metastore will be a bottleneck. So you'll have one Metastore, you will scale up multiple Metastores. Metastore could be a bottleneck if you're overloading the Metastore. So using these are the challenges we have at present. So apart from that, the last one is interesting, like the schema evaluation and partition evaluation. So for example, if you have a table, if you want to change the partition from year to month, so basically what you do in legacy Hive, you have to recreate the table to change the partition. But in Iceberg, you can do a live table. You can do a partition evaluation. So that's possible without recreating the table. That's possible in Iceberg. Yeah, this is how the complete big data architecture looks, right? So we have multiple compute engines, we have multiple storage layers, we have multiple other services which have not included, say like, for example, HP, Kudu, these are some of the services are not included here. So we have multiple services in big data world, right? So where Iceberg fits into is, it's a table format. As I said, we already have file formats. It sits above your file formats. It's basically a table format. As you could see here, it's a table format. We'll discuss the features of Iceberg and why a table format is required. We'll discuss on that further. So also it supports all the cloud storage. It also supports the legacy storage like HDFS, Ozone, and all the cloud storage it supports. So this is basically Iceberg's architecture. You can say like what we are doing different or what are the internals of Iceberg. So basically we have if you just imagine a Hive table, right? So how it will look like, we have a Hive table, we have a structure of database, tables and partitions. We'll have that hierarchy, right? So when you go for an Iceberg, so here it has its own architecture, like say like it has its snapshot, that's a higher level. Then you have manifest list, and under that you have manifest. The last layer is the data. So where your physical data presents. So as you could see here, you have a table, you have metadata, you have data. These are the two main directories. So data is nothing but your physical data where it's on your HDFS or in your cloud storage. The metadata is about the data. It creates a metadata JSON. So that points to the actual data. Say, for example, whenever you do an operation in Iceberg, it creates a snapshot. If you do an insert, it creates a snapshot. So when we say a snapshot, a single table can have multiple snapshots. So using the snapshot, you will get a feature of say like if you want to roll back, or if you want to do a time travel, these are possible using these snapshots. So one of the main feature is Iceberg partitioning. So how partitioning works, right? So again, when we talk about a bottleneck with HMS, right? So if you want to read a table, say for example, if you're running a select on a column which is not a partition column, you're running some query on that table, it basically scans the complete table, it scans the complete partition, complete files. So say like you have, as I said, like 10,000 partitions and 1 lakh objects in the complete table, it scans everything. So it takes time. The file IO operation takes ideally time. So what we are doing in Iceberg is basically we are segregating here. So here basically we are segregating the partition part into Iceberg. So Iceberg manages the partition. So when you create Iceberg table, HMS doesn't know it's a partition. So the partition is managed by Iceberg. So when we talk about Iceberg, right, it's not a component, it's a library which sits with multiple engines. So we have Hive, Spark, Impala. Also we have open source DBs, right? It also supports other DBs as well. So the advantage of using Iceberg is like it's engine independent. You can create, if you have an Iceberg table, you can interact from all other engines without much dependencies. Say for example, if you have a Hive table with ACID, if you want to access from Spark, you need some HWC dependency, or if you have to go through certain way to HS2 to get connected to HMS for an ACID table. So those dependencies will not be there if you're using an Iceberg table. So the last line, if you see, like Iceberg relies on HMS, but it reduces the pressure. So still it relies on HMS because the table's information still gets stored. If you do if you create a table, we have TBLs in the backend, we have certain tables, right? It still stores the structure of the table in the backend database, but the partition level information just doesn't get stored in HMS. It's managed by Iceberg. We'll see that in an example. So this is what one of the line which I was explaining. So if you're using a regular Hive table, right? So basically it tracks only about the folder. It only tracks about the folder level of data, say like user, Hive, warehouse, DB, and table, and partition. HMS only knows about that information. It doesn't store file level informations. So that's one of the problem. So we have two layers. So practically this problem mainly solves most of the issues customers face in the cloud storage. Say like if you have HTFS as a solution, right? Most of your calls will happen within the cluster. Every call will be a TCP call. Every call will be local within the cluster. When you use a cloud storage, right? Everything is an external call. And if you run MSCK repair, or if you have automatic partition discovery, those kind of stuff, right? So basically you are making more calls to the cloud storage. It also ends with API cost, S3 API cost. That's one part. Also, it takes time. So we have a file system, we have HMS, but both are not together actually. So both works differently. So to solve that only, they have integrated this particular library with other engines to make the performance much better. So basically we have HMS, the schema gets stored there. We have a snapshot, and we have a metadata pointers. Basically, whenever you create a snapshot, it will have multiple metadata files. So the current one will be active. For example, if you're, you can do, it also supports ACID. You can do if someone is writing, right? So they can write the data. If someone is reading, they can read the data at same time they can do. So it also supports the atomicity, like we have in Hive ACID, right? Similar things are supported here. So this is the key feature why we are focusing our customers in public cloud or in general world, right? They're using Iceberg for, they're looking Iceberg for. These are the main key features. So one is the snapshot isolation. As I said, like if a user A is writing, so he'll have a separate snapshot and pointers. If user B is reading, he'll have a separate snapshot and he will be doing his operation separately. So that's snapshot isolation. Then you can do time travel. So based on the number of snapshots, you can say, for example, we have seen multiple issues like data has been deleted, or we want to go back. What change has been done, we don't know. We want to go back to the previous state. These are not possible with current Hive unless you manage it somewhere externally. But if you use Iceberg, this does everything for you in build. So it whenever an operation happens, it creates snapshot. It maintains the action what has been made, and you can use a query to go back and see what happened during the time frame. That's one thing. And the other thing is table rollback. So this is one of the feature which we don't have in Hive by default, right? So which we have in regular RDBMS. Like if you want to go back, roll back to a previous state, you can do. So here also you can do using snapshot using Iceberg. Snapshot ID, we'll have a snapshot ID, or we'll have a time travel ID. So in-place partition, in-place table evaluation and table maintenance is basically when the snapshot is growing, right? Your data is also growing. Say, for example, if you have 10 snapshots, you will have 10 kind of same data within the system, right? So you have to control the snapshot growth. So either you have to, there are table maintenances like we have compactions. So that is done using CDE or Cloudera data engineering platform that runs on Kubernetes and using Spark 3 and CML. So these are the tools which we use to do the table maintenance activity for the snapshots. And you can also define the snapshots, like how many snapshots you want to maintain for a table. So if you want to maintain last 10 changes, you can mention like 10 snapshots. And it supports ACID transaction, as I said. So below are some of the cloud features which we have, like SDX integration. It talks with Ranger RAS, and you have Kerberos, and you have all other security mechanism in place. So it supports multi-cloud. So we have AWS, Azure, and GCP. Performance-wise, like one of our customers using Iceberg with Impala, and they found like 10x performance difference compared to their legacy Impala data warehousing solution.
Okay.
Yeah.
So my question was regarding this security. So how Iceberg knows what kind of privileges user have?
Right. So basically, Iceberg is not a component. As I said, it's a library which integrates with Hive. So generally, Hive or Spark or Impala, how it works, it's going to work in the same way. It's going to have the authorization and the authentication. You'll have a Kerberos or some kind of authentication you'll do. Then it'll have Sentry or Ranger, what kind of authorization you have. So in public cloud, we have something called Ranger RAS. That's an additional feature. So which has a cloud level data governance thing. So it's Iceberg is not a different thing. It's just a library which sits on multiple engines.
It's catalog responsibility to handle auth and auth.
Yeah.
So if we added a policy for Hive, does it applicable for Iceberg also?
You're right. Because it's not a separate thing, right? So basically, it's engine independent, but it's all based about the user, right? Which user you're logged in. If you're logged in as Chelapan, so whatever access he's having for the table, he can do.
Like all database, all
tables, or if you're specific to a specific table, the regular architecture, it doesn't change. It's only changes the internal part of it. So maybe, as I said, the compilation will be different, performance will be better. Then, so these are some of the key things which happen centrally.
Hi, Shilaban.
Yeah, hi.
You said like it's 10x faster than Impala.
Yeah.
So does it use some different execution engine?
No. When I say 10x faster than Impala, Impala is the engine. Without Iceberg as a table format, say like you have normal regular file formats like Parquet or something, customer is using. If the query is running in 10 minutes, if they use Iceberg integrated with Impala, then the query runs in 1 minute. So that's the 10x. So engine still stays the same. It's Impala. But how we compile the query, how we process the query, it changes using this table format. As I said, like, not sure you were there before. I'll just go to this previous slides. So Iceberg sits here. So basically, Iceberg is a table format. So we already have file formats. So we know how a table structure looks, but we don't have a proper bundle mechanism to manage all the files. So that's where Iceberg comes into picture. You can bundle all your file that is maintained by Iceberg. You not have to always go to your HMS and go to the backend database, and you have to do a number of calls and things. So the library knows by itself.
So like data mart and real-time data mart, we have one like public cloud.
Yeah.
So can we use like independent Iceberg service as well there?
Yeah. So again, Iceberg is not a separate service or a component. It's a library. Say, for example, if we want to talk in CDP perspective, right? So if you're using CDP public cloud release 7.2.16, by default, it comes with Impala, Hive, and Spark. And then Spark, the version should be 3.3. So it doesn't support Spark 2.x.
That answers my question.
Yeah.
Thanks.
Hey, hi. Can you able to hear me?
Yeah.
So I'm talking from Zoom. Yeah.
Yeah.
So does Iceberg change how Hive stores its data, like in the storage?
Yeah. So when we create a table, you're saying like I'll show the statement how it looks like. This is our internal document. When you do a create table, right? And you do a create table, and when you say the table is stored as Iceberg, and you create a table, and when you say the table is stored as Iceberg, basically HMS doesn't even, say in case of partition table, HMS doesn't even stores it's a partition table because the partition part is taken care by Iceberg library, but still the table metadata sits on the HMS.
Okay, so there will be no partitioned folders in storage?
It will be there in storage, but HMS doesn't know it.
Okay, got it.
Yeah, the HMS backend, I mean. Yeah.
So
we
when
have, go ahead.
so when I want to fetch that data, so I will talk to HMS and HMS will internally talk to Iceberg.
You are right. It's integrated library. So as I said, the flow, right? When you do a normal query flow, only it goes in like authentication, authorization, HS2, HMS. Then it goes to Iceberg.
Okay, got it. Okay, thanks.
Yeah, Chalam. I have one question. So can we use Iceberg without the HMS?
No, it needs some kind of catalog. So as I said, it's engine independent, but it's not a component by itself. So it needs some kind of component backup. So we need some kind of engine to run, and it has its own catalog.
So I have used Delta Lake before. So
Yeah.
it maintains a folder underscore Delta log folder, and let's suppose I'm reading from Spark or let's suppose I'm reading from Rust. So it basically reads that folder first and then reads the data. So in Iceberg there is no such mechanism. So you need to have some sort of meta store in between.
Yeah.
Am I right on that?
You are right on that. It needs metastore. So when we talk about Delta, right? So it's from Databricks. So we have multiple other table formats as well in the market. So we have Delta from Databricks, and we also have OD that's used by some other customers. So, but CDP, which we have chosen Iceberg as a default file format. And to answer your question, like we need HMS for storing the structure, but the table stats, the stats information and partition informations will be taken care by Iceberg.
Okay, thanks.
Yeah.
Okay, one more question I have.
Mhm.
So if I store that table in Iceberg format, use the same data to create, like for example, an external table, just without Iceberg, like can it handle? So
yeah, if you are creating a table without Iceberg, it acts as a normal table. So if you are using Hive 3, it stores the file format as ORC and it works in a plain way. Yeah.
okay, got it. Thanks.
Yeah.
You just mentioned that CDP is going to use Iceberg as a default format. Can you
Yeah,
elaborate?
file format. I've used the word, yeah.
I mean,
It's a table format, yeah.
yeah. So when you'll try to create a table using CDP, so default format will be Iceberg.
By now, it's not a default format. So there are plans. So we have multiple customers, right? So there are like over like 5 zettabyte of data Cloudera customers using over the world. So for now, we are not pushing this as a default table format. It's only available in public cloud and data services. We'll come to private cloud also. So coming years, next 3 to 5 years, it will be the default table format.
Okay.
But if you can still store as another other options also will be available. Whenever we say default, it's going to be default in the future, but it's not now as a default.
Okay.
For now, you have to use the syntax whatever is shown you, stored as Iceberg. I have just few more slides. So these are the components we have in public cloud. I'll also show the UI. So basically, these are the components which interact with Iceberg. So we have data warehousing solution, data engineering solution, and machine learning. So these 3 runs on Kubernetes. So basically, how we will get the data to Iceberg, right? When we are saying Iceberg is coming in, so we need to somehow get the data to Iceberg. So what we basically know our customers are already using Hive tables. So we have an option to do a in-place migration. If you're having an Hive external table, you can use some certain commands. Using that commands, you can directly convert your existing table to Iceberg table. I'll show you how it works. Yeah, this is the command. If you see like the first one, alter table set property. The storage handler is, you have to just change the storage handler pointing to an Iceberg storage handler. So this will only work for an external table. You have to have a Hive external table. And if you ask me about the file formats, Iceberg supports ORC, Avro, and Parquet. So if you have an external table in these 3 formats, you can directly convert to an Iceberg table without doing anything. So when you convert, right, what happens? It's an in-place migration. So what happens is like the file doesn't change from the source location. It stays on the same location. But for Iceberg, it creates the metadata. It'll have a snapshot, manifest list, and it'll create the manifest, and it'll point to the same data. So this is for in-place migration. So you can do the same thing from Spark. As I said, it's only supported in Spark 3, not on Spark 2.x. And this is about table migration. In case if you want to do a kind of a managed table, or if you want to do a CTAS or RTAS operation, right? You have to follow these commands to, during CTAS or RTAS, the data gets again written. So it will take time. It's not going to be a simple exercise of changing the storage handler. When we do this part, it's going to take time, because it's going to rewrite the data from one place to other place. As we speak on, let me check if I have some active cluster also. Sorry. Yeah, for internal tables you can do. For internal tables, what happens is it will rewrite the data. It can't point to the existing one. It will rewrite the data. You can do. Screen is still visible. No. Something. We share it.
Okay.
Just bring back again. Yeah.
Recording in progress.
Okay. So I'm
Who's sharing screen?
maybe my previous one. Yeah. Okay. Sorry for the glitch. So I'm audible, right?
Question is, yeah.
And issues. So it's still audible now? Yeah.
Yeah. If snapshots are increased, right?
Uh-huh.
How it is handled?
Am I audible? Okay. So we have something called table maintenance, or the snapshot maintenance. As I was saying, you can maintain like 10 snapshots or 100 snapshots based on the operation you do on the table. You can define that. It's configurable. I'll show you. That's the next topic actually. After showing some kind of demo or something, that is the next thing I'll be doing. We switch back to the UI.
You want the
So this is CDP control plane, public cloud control plane. This is how it looks like. We have multiple offerings. As I was saying, we have CDF, that's a data flow. Then we have CDE, data engineering, data warehouse, operational databases for HPs, data warehouses with Hive and Impala, and we have CML, that's machine learning. So we are going to do is like, we'll get into our management console. We have an environment in 7 to 16. I have created a data hub with Spark 3, and it also has Hive in it. So we'll go to here. So this is some of the testing I've done, not in Iceberg. I'm just creating a test table without any data, and I'll show you how it looks. Show create table on test 1. So as you could see, the storage handler stored by Iceberg, and the location is our table location. Main thing is this metadata location. So whenever we do an operation, this metadata pointer just keeps on changing. I'll show you by doing an insert operation. Right. I'll just do some couple of inserts.
Chalapan, I just have a doubt. You told that Iceberg can set on ORC, Parquet, and all these things, right? So here, I mean, what is that? What is this format, file format?
The default will be Parquet. Let's check that out. Still, we not created a data, right? We'll insert some data and we'll check it out. It should be Parquet.
Okay, so let's say when you're creating a table, right? So you mentioned stored as ORC or stored as Parquet. So when creating a Iceberg table, so we don't have to mention the file format. We will mention stored by Iceberg. Then we can put what do you say, ORC data or Parquet data. Is my understanding correct?
You are right. So we will not specify the file format when creating the Iceberg table. The file format speaks by itself. But in case of migration, right, there are two kinds of migration. One is in-place migration. If you're doing an in-place migration for an Excel table, what is the source of the Excel table? It will retain the same file format.
Okay.
Yeah.
And in case of one more to CTS or RTS, that type?
So that time it's something similar to insert what we are doing. It should be Parquet. We will check it out. I'm just inserting some data. We'll check it out now.
Okay. So in case of Hive, the default format is ORC, right? Iceberg override it?
Yeah, Iceberg also supports ORC, but by default, Iceberg creates a Parquet. Just will check it out quickly. Just we have inserted a data. We'll just think it should have. Yeah, as I was saying, whenever we do operation, it will point the metadata location to previous and current. And we have to list this path, and we'll check how the data is inside this path. As I said, there will be two directories. One is the data directory and one more will be the metadata. Maybe we'll try show files. I'll just create a DB catalog. Shouldn't take much time. Maybe we'll discuss something and we'll come back here. Wait, hold. So this is our document which talks about the file format which it supports. So this is the thing I was trying to explain. So for some reason it's getting permission and I have to check that part. So by default it stores as a packet. So Ashish, does that answer your query? We'll quickly do maybe one more insert. It's done. So table type. So this is one of the additional column which get added. So whenever you create a table with stored as Iceberg, you will get a column called table type. Then we will go for time travel. And then if you run the show create table now, it will have 2 metadata locations now, since we have inserted 2 times, right? So it will just show the previous and current, but if you go to the data location, it will have overall 3 metadata files has been created on that. Metadata JSON will be created. So always we will have the previous and the current one. So this is how it looks.
So when we store table as an Iceberg format, will it be treated as external table always?
No. So since we are talking about, okay, here we have not specified as an Excel table, still it takes an Excel table. Looks by default, it creates an Excel table. Yeah.
Okay.
Yeah. Let me try to access some existing cluster. I think this thing is working now. I'm just creating a DB catalog. Should be up in 2 minutes. So meantime, we'll complete the slides. So we are talking about the table migrations, right? I'll show it once the DB catalog is up. So this is the table maintenance. Someone was asking question regarding to snapshot. So this is how you can manage your snapshots. You can specify how many number of snapshots you want to manage. But the management part is taken care only by Spark for now. So Hive doesn't do the table management. So we need, from CDP point of view, we need CDE or CML as a service or Spark 3 to do the table maintenance activity. So these are the features again, so we can set a snapshot expiry as well. So if we set 7 days, after 7 days, automatically the partition will get expired and the underlying data will be removed. So creating it. And maybe if you have some questions, I can take up.
Dilpan, in the metadata section, there were previous and current metadata, right?
Yeah.
So the previous metadata contains the last changed metadata, right?
You're right. Yeah. If user is, yeah, go ahead.
Yeah. So let's say, I want to switch back to, or three. Let's say I have not set the expiry time or table maintenance. Okay, so I have 10 metadata. So let's say I want to go to 8 metadata. Okay, and I want to switch back. So can I do that?
Yeah, you can do that. That's the time travel. Let me check. We'll have, yeah, this is the feature you are asking about. So we have some system internally, Iceberg creates some system table. So we can select from the table and we can see what are the things available. Let me run those queries. Maybe.
Okay, we can just view it. Okay, I mean we cannot configure it again, right? Reconfigure.
Okay, then that's something called rollback. If you want to go to the previous state, that's what you're asking, right?
Yes, correct.
Yeah, rollback feature is available.
Okay,
You can go back to the previous timestamp. If you go to the previous, say like 6th or something, so the consecutive one will not be there. Say for example, there are 10 changes made. If you want to go to the 6th one, so you will not have 7, 8, 9 ideally.
I didn't get that.
So when we say rollback, right, there are 10 commits. Okay. If you are doing a rollback to a new table, that's fine. Maybe pointing to a metadata or something, we have multiple features. But if you, within a single table, if you want to go back to the 6th change, so you will not get back your 7, 8, and 9 change.
Okay.
Okay.
So
for example, someone has deleted the data. If you want to go back, you can go back, but intermediately, if some other change is also done, you'll miss that. So basically, which snapshot or which time zone you are saying, if you want to go, it will go to that time.
Okay, fine. Got it. So, but in that show create table, the previous metadata only will be shown. Okay, the other things will not be shown. I mean, the last 6, 7, 8, that will not be, that metadata will not be shown. Correct?
Right.
Okay. Thank you.
Sure. So these are the two columns. One is the timestamp snapshot ID and the timestamp.
So Tilipan, I just have one more question. So, so the snapshot contains, right? So that data and metadata change both, right?
You're right.
So let's say, for example, I have done some changes. Okay, so on 6th, on 6th, what is the 6th metadata? So I have just altered the table, or let's say I have dropped one column.
Okay,
I have dropped one column. Okay, on 6th one. Okay. So let's say, let's say I'm doing a time travel. Okay. So then on that metadata, that column information is there, but actually in the HMS that column itself is not there. Then how does Iceberg handle in that scenario?
So you're asking about how the metadata will get updated in the HMS backend. Is the question, right?
Yeah, because the metadata is not there right currently. Let's say I'm doing a time travel. Okay, so in the time travel one, okay, so that contains the old metadata and old data also. Okay, let's say that let's say ID column. Okay, ID column itself, I'm moving it. Okay, so right now in this on the previous time travel data, okay, the ID column is there, that metadata is there, and the data is there. Let's say I'm switching back to that one. Okay, then but in HMS, but it has to go to HMS to fetch the information. That column is not there. But again, in that time, how it will be handled?
So that's how the table evaluation feature comes in. So basically, it will recreate the particular column. It will have a metadata JSON, right? It knows how the table was at that state. So basically, it will create those columns which are missing, so which are got dropped.
Again, you want to say it is going to create the column again in the HMS data, HMS.
You're right. Yeah. Once you remove it, it will be not there. But when you do when you say, like, if you want to go to the previous state, so the metadata JSON, it's going to do a table evaluation. So by that, it will change the schema. So whatever present on the existing schema at that time, it will go back to the previous time. So if you could drop a column, the column will get added back.
Okay, got it. So whenever we are doing a time travel, so it always does the table evaluation backend, correct?
Yeah. So time travel is just a snapshot kind of thing. It will just take and show you. But if you do a complete so I'm just trying to show a demo. For some reason it's failing. Let me check whether it's DBC is up. I'll quickly create a virtual warehouse. Because this is preloaded data with Iceberg. Just creating a small one. Shouldn't take much time. So this is our data warehouse experience in meantime, this UI thing, right? So we'll have an environment, we'll have a DB catalog, and we can create multiple virtual warehouses on the runtime. So you can create a Hive or Impala virtual warehouse. No, just starting. Sorry, just not on waste. It'll have to be up in 1 minute. Yeah, I can do it. So it's still thing is on. I can share it once it's started. I'm sharing back. So virtual RS is up now. So I'll just do the similar thing what I did in the data cluster. I'll do it on CW. So this is one of the Iceberg table. So if you see this option, which means like it's migrated table. So you have this table is migrated from an external Hive table, and you could see for now this table is partitioned by year, right? We will try to do the partition evaluation. We'll try to add partition column, one more partition column as month for the same table. Yeah, this is the syntax. So basically you have to do a alter table name, then you have to use a spec. So I just added a partition for the existing table. You'll see the show create table again. So as you could see, like this table is month has been added. Previously, this table was partitioned by year. If you see, month has been added. So this is the one of the feature. Without rewriting the table, you can just add a partition on the web table. Yeah, that's it from my end. If you have no more questions, fine. So Ansari, over to you.
Chala, there is a question in the Zoom Q&A.
External table type and location is set default due to we are in public cloud, right? So when we have a CDP public cloud environment, internal and external location like exists by default, like we have in on-prem. So even though you have a location, right, you can still do in-place migration or you can still create a new table. So default locations will be there. Still, you can do other operations like you do in Hive, because Iceberg is not changing anything in the Hive behavior. It's just a additional library which gets integrated with the existing engine. I hope that answers the query. Okay, thanks. Yeah, you can do that. So as I was saying, like you have a file system. User A is writing a data from Hive. He will have a snapshot. He'll use the latest metadata. User B is again reading from Spark. He will have its own metadata. He can do it. So that's where atomicity comes into picture. So you can do isolated. That's where the snapshot isolation works in. You can still use multiple engines, same data. HMS as a catalog. So Iceberg use its own catalog. So in Spark, it has its own catalog when creating. So similarly in Hive, it uses HMS itself. Internally, it will have its Iceberg catalog. It's an internal part of the library. You can't see that as a separate component. It's an internal part within the library.
Table A is available in catalog.
Right.
For example, now I am using Hadoop catalog.
Okay.
Like that, reading data from HMS.
Multiple catalog is supported. Yeah, because we came across like customers using cloud storage as one of the catalog, and we also have legacy Hadoop catalog, as you stated. So it does support multiple catalogs. Still V2 is in progress, so I'm not sure like how the things will work with ACID further. It's in early stage. So yeah, based on engine, it uses its only one catalog.
Thank you very much, Chella. In case you're wondering, that camera is active, so that's why I walked up. So people on the call will know what's happening. Doesn't look like a voice from the back without a face. Okay, so the next speaker is Foco. He works for Tabula. It's a company started by an ex-Cloudera. It focuses on Iceberg. And Foco is an open source enthusiast, as you can see on the screen. They provide a managed data architecture on Apache Iceberg. He's an open source enthusiast. I think I said that already. He is a committer. He's an Apache, an ASF guy. He's part of that. And he also commits to Parquet, Avro, apart from Apache Iceberg. And he believes in knowledge sharing. So if you have any doubts whatsoever, you can find him on Apache Iceberg Slack and ask him. He's a nice person. If you have any doubts whatsoever on Apache Iceberg, you know he's the guy. He knows it at a code level. And over to you, Foco. And thank you very much. It's very early for him. He's in Denmark. So thank you very much. Over to you. You're on mute.
Thank you. Yeah, I don't use Zoom that often, so I have to find the buttons again. Thanks. I'm actually in the Netherlands, so it's 6:40 in the morning here, but I'm very honored to be here and to talk about Iceberg today. Let me get up my screen. Yeah, so first, thank you, Chella, for the excellent talk. I think you covered like a lot of the content about Iceberg. I think there's some overlap there, so hopefully, we'll just tell it from a slightly different angle. You still learn something. So a few words about me. I'm Foco Driesprong. I work as an open source engineer at Tabula, mostly on the open source side. So a lot of work on the Iceberg, especially on the PyIceberg library. My GitHub handle is Foco. So if you have any pull request or any issue, feel free to just mention me there. You can also reach me over email, or I'm also in the community Slack of Iceberg. Like Mohammed said, I'm a member of the Apache Software Foundation. I'm committed on Avro, Parquet, Airflow, and Druid. So if any bugs in there, you can blame me. Always feel free to reach out if you have any questions. So I'm a father of Jitse, and the second one is coming in 3 weeks, like the expected date. So it was a bit of a doubt if I'd be able to speak here today, but I managed. So what is Iceberg? It's always about the definitions, right? So the best one that we came up yet is like Iceberg is an open standard for tables with SQL behavior. What we mean by open standard is that it's like a specification. The Iceberg, in the core, it's like a specification. It's like a markdown document that actually specifies like how we write like these manifest list files and manifest files, the data files, and all this kind of stuff. How the Iceberg schema looks like. This is all formalized in a specification. Currently, we're at version 2 of it. Version 3 is like being developed, and it's all open source. So a lot of companies they interact with the Iceberg community just to make sure that we get like support or like integration with like a lot of different companies. Personally, I believe like if you develop like a standard together with like the big companies in the world, you probably get like a better result than doing something inside your own company. And it says like tables with SQL behavior. What we mean by that is that at some point in time, we actually lost like a lot of the SQL behavior. So if you go back in time, like 20 years ago, you had like SQL and Postgres, DB2, and the storage, the database where like storage and compute was directly coupled. That had some issues, but it had like very strong guarantees. So for example, updates, deletes, everything was like fully ACID. When we moved first to Hadoop, we said, okay, let's decouple like storage and compute. It gave us a lot of scalability, but also, we lost a lot of the nice guarantees, right? Like when it comes to correctness and concurrency, isolation. So along the way, we lost some stuff there. But that's actually what Iceberg is bringing back. To the cloud space. Iceberg originated from Netflix. It was actually solving like 3 issues. Most and foremost is cost and performance. If you store like petabyte size table in S3, it's going to be expensive. Especially Iceberg help you to lower the storage, mostly by compression and tuning settings. And also it helps in terms of performance because it has like a lot of optimizations in there. For example, I will go into this deeper, but it's very easy to just like skip like whole files, these kind of things, stuff that we didn't really have before. And it actually gives like this 10x performance benefit that Chella just mentioned. Data engineering productivity. As a data engineer, I worked in data engineer for like 8 years now. Analysts come to your desk, say like, "Oh, this query is so slow," and you have to fix them because that's in the end bring like the business value. So you have to make sure that your analysts are productive. But that's for me not the most exciting work. I'd like to build like new tools instead of like fixing existing stuff. This is also where Iceberg really helps. It gets all of this repetitive stuff out of the way. Incorrectness issues, and that's mostly about like table versioning. So, and just getting back to this asset state where you can give some guarantees about the table that makes sure that everything is correct and that you can rely on the issues and not someone is writing and reading at the same time and you get in some kind of race condition. That's all handled by Iceberg, so you don't have to worry about it yourself. By the way, if there are any questions, feel free to interrupt me. This is the first time I give this talk, so probably there will be some gaps. So feel free just to make it a bit more interactive. Just pick up the mic and just shoot at me. I think one of the strengths of Iceberg is that it's supported by many different compute engines. So we see like just a list here, and it's definitely not exhaustive. For example, recently also ClickHouse said that they're going to the pull request has emerged. So in the next version, they will actually support like Iceberg. So you can plug in like from a lot of different engines into your Iceberg tables. So it's not locked into one single vendor, but you can just the data should be in your own control, and that's where Iceberg is helping as well. So when developing Iceberg, and the main question was like, what if we apply database fundamentals? Maybe this the Hadoop, for example, when we started, it was like just a bunch of CSVs on HDFS. And it was just like, when you do a query, and you validate on reading. So you start reading like these things. And if like an additional column comes in, you give like an error. With Iceberg, it goes back to the database fundamentals. Like if you change something to a table, if you insert it to a table, it will be checked at like insertion time. Like, is this like compatible schema? If not, then it will give an error. If it's compatible, then it will be inserted to the table, and then you're sure that you're in a correct state again. Also with like schema tracking, I don't know if you ever tried to do like evolve tables. It's quite hard with HDFS to apply to a lot of rules. Also with Parquet and HDFS, that's what I mean. That's also where Iceberg makes your life a lot easier. So let's dive into some of the things that Iceberg solves. So one of the main things is schema evolution. It's instantaneous, so it's all being kept into the table format level. So if you add like a column to a table, it will not start like rewriting all the Parquet files underneath. It will just like do a metadata operation to the table format, saying like, oh, we have a new column, or this column is not an integer anymore. Now it's a long, and it will automatically like do the widening of the fields for you. Support for updates and deletes. There were some engine specific ways of doing this. And with Hive, you had like you could like do updates and deletes. But Iceberg, we said we don't have to do this in an engine level. We have to actually push this down to the table format level, so that each engine that you use to plug in to the table has like the same behavior. It's like safe, it's asset compliant. Like I said, like if someone is writing, someone else is reading, they don't interfere. If you add like a column, all the existing queries that are still running are still will still finish to completion with success. Also surprises, no undead columns. Might ask what are undead columns. So for example, in Hive, if you try to delete drop a column and you add it again, you will see like the original data. That's something that we definitely don't want. And with Iceberg, these kind of cases are also fixed on a table level. Yeah, one of the, like in the beginning, I said like Iceberg offers like a big performance improvement. Mostly this done by partitioning. Just a reflection on traditional partitioning in Hive, you would have to create like a partitioning column, in this case, event date, and you would also have to explicitly add this column to your insert statement. What's very important then when you query it, that you also include like the event date column. Otherwise, it will just do like a full table scan, and your query will be like 20x lower and 10x more expensive because of all the calls that you have to do to S3, and because you need like a bigger cluster and all these kind of things. This is from the Iceberg documentation, so if you want to dig further in this, feel free to just follow this link. And what's very important here, that you have to educate your analyst on this event date, right? If they don't add it, it will like, the query will explode and it will take a lot of time. And in Iceberg, we said, yeah, this is not a problem of the analyst. Like this comic is saying, it's like a problem of the table file layout. So instead of educating your analyst, the file layout should just transparently handle this for you. So in Iceberg, you can just say all the table logs are at partition field days of event time. You don't have to inject this column anymore. It will just be derived from that event time column. Yeah, so also everything is lazy. So it only will rewrite when it's actually needed. And it's very hard to do a big design up front, right? We never know like how a table is going to look in 5 or 10 years. So Iceberg is also focused on just correcting these kind of things later on. If you, for example, partition on a year, but you want to change that partitioning into a month or even a day or hour, that's all possible with Iceberg. Yeah, I like the demo, so let's look at this. Is my screen visible? Cool. Thanks. So this is a very simple setup. It's also available on GitHub. If you want to try, give it a try, it's a Docker Spark Iceberg setup. Just like a very simple Docker compose to get started very easily. So let's create like a simple database. Let me just, yeah. So what we do here, we create like a database called New York City, and we create a table, New York City taxis. Right now I do it explicitly. Probably you're familiar with this data set. It's like the taxis data set. Has like a pickup time, drop-off time, passengers, and some amounts. So using Iceberg. So just make sure that it's an Iceberg table. And right now we do the performance version 2. Performance version 1 works just as well. Performance version 2, like deletes and updates have been added. So that's also nice to show. And it's partitioned by, in this case, years of the pickup datetime column. So when doing here, using PyIceberg, looping over these 4 Parquet files and just appending them to the table. I do them one by one just to make sure that the memory pressure is not that high. If you then look at the data, we can actually see like the table itself. And for example, if we add like a column, we say like add column tip rate after tip mount. And then we see like the new column being added. You can also edit, fill the column, and this is now like actually rewriting actually all the data. So what it will do, it will create like a new snapshot, like Shadowpen created, explained, and then create like the new Parquet files with this column being added. If we look at the data then, and we see some very weird data, like the fare was just like 1 cent, and the tip was like 205 USD, I guess. So, or there's some very bad data, or there's some money laundering going on here. We don't know. Let's talk about partitioning. So right now the data is being partitioned in on a yearly basis. And you can see like this 38 means like it's 38 years from 1970. So it's actually 2008. And it will also tell you like the file. So these are actually magic columns. So we have like underscore partition, underscore file. These are available using Iceberg. And it will tell you information about like, for example, if you like this, like where the file is, of where the row is coming from. It just helps me just to debug like this. But also tells you like where the data of which files you have. Right now you can see like we have just a standard partitions over there. So let's say that the data grows very rapidly, and we do a lot of queries on smaller granularity. So then it makes sense to narrow down like this partition field. Having like very granular partitions is nice because it has better compression. You get like bigger files, and the smaller granularity is nice if you do like, for example, filter on a couple of days of data, and then you don't want to look at the whole yearly partition. So what we're going to do is say audit table, usually Dexy's drop partition field years is the one that's on there right now. And we're going to add like a new one called months. This all instantaneously because we don't need to rewrite any data right now. And as you can see, if you add like the monthly partitioning, then the yearly partitioning can go, because the monthly partitioning is actually implies like the year. All right, so if you know like which year, which month in which year, then you implicitly also have the year. Maybe a good distinction. So if we look at the partitions then we can see that's still the same because we didn't do any rewriting. And then you can, for example, you have these procedures like rewrite data files, remove orphan files, rewrite manifest, and these are used to do table maintenance. And if you call these, they will actually start rewriting the file. So right now, Iceberg will see like, oh, you have like a new partition specification. Let's convert everything from yearly partitions to monthly partitions. And now they'll start rewriting all the data. You can also put like a where clause in it. If you have like a huge petabyte size table, you probably don't want to do it like all at once, but you can also say like, okay, I want to do it like year by year, just by adding like a where statement. Right now we can see that also has like the month in there, and we have much finer granularity partitions. Yep. yeah, there was like a very small demo on just showing like how easy it is to work with Iceberg. And these things I think were quite tricky in your Hive partition table, like changing like a partitioning level. And in Hive, I would like probably rewrite the whole table and make like scripts for that. But for Hive, it's just like something that's baked into the file format. Yeah, so Apache Iceberg is the foundation of cloud-native data platforms. What we mean by this, we have a lot of additional files, like Chelpano also showed. And for example, on HDFS, it's very efficient to do like a list, because you just go to the name node, right, and you fetch like a list of directories. But in cloud, this is not the case. A list on S3, it's quite expensive because it has to do a scan. And Apache Iceberg gets rid of, for example, a file listing and just fully focuses on having direct GET requests to the specific objects that you actually need. So Iceberg is designed to be the center of gravity. You don't want to copy any data, ideally, right? Because you get like different versions, one in AZFS, one in S3. And yeah, they will definitely diverge. So with Iceberg, it's designed to be in one single place. It unifies batch, streaming, and ad hoc. So yeah, batch is easy, right? Streaming gets harder, but it's very easy to stream inside of a Iceberg table, because with this asset compliancy guarantees, you can just append like new files, and the existing jobs that actually read from the table, and they will just continue to work. And we support from the Iceberg like any language framework. So and you can integrate with Impala, you can integrate with Spark, even with plain Python. So it gives a lot of flexibility. Yeah, it's focused on making people productive. Like, don't want to spend on things on maintenance, time on maintenance, has strong guarantees, and maintains data in place. So not a lot of moving around. So maybe we can take one step deeper and just go to the format again. So as you can see in the table itself, I use the REST catalog, so that's a bit different than the Hive catalog. But it points out to the metadata JSON that has like multiple snapshots of the table. Snapshot is like a version of a table in time. One snapshot points to one manifest list, and manifest list has all the information about like the partitions. So if you select like a certain partition, for example, that we had like previously, you select like on a specific day, the days inside of a month. So then we know like which partition we need to read. And we can just leave all the other partitions. We don't have to touch them, so we can just prune them in that sense. Then we go to the manifest. Manifest is like an Avro file that actually points to multiple actual files, also of the Parquet files. And these manifests are also metadata. So what we have in the manifest is, for example, for each of the columns inside the Parquet file, we keep like the min max. Also the number of nulls, and these kind of statistics. And this also helps to speed up the query. So if you're looking for like a value that's not in this Parquet file, then we can completely skip the Parquet file, therefore also optimizing for performance, because we don't have to read the whole file, and also for costs, because we don't have to do any GET requests to the object store. And also third, actually, also your compute also gets cheaper, because the job gets simpler, there are fewer tasks and fewer calls. And layout optimization. So if you want to change something afterwards, if you made like not the right decision on how to layout your table, you can also fix this later on. And also, when we did like the rewrite data files, what it also tries to do is like to create like big, nice and chunky files. So both ATFS and also like the object store don't really like a lot of small files, because it introduces a lot of overhead. And also with Iceberg, you can just compact like these files in the background. The user won't notice, until next time when they read the data, it will be faster. Yeah, so Iceberg is quite a big and active community, originated from Netflix, but we see a lot of other companies also investing a lot into the open source system. So yeah, that also gives like a lot of very strong foundation. Yeah, so how does this look? Yeah, Iceberg is like compute independent. So with each of the technologies that you like, you can plug into an Iceberg table. Iceberg is very tightly coupled with like a catalog. For example, the Hive catalog that we saw in the talk before. But you can also use like managed catalogs like AWS Glue or the REST catalog. The REST catalog is like an open specification also provided by the Iceberg community. Instead of using the traditional Hive Thrift interface, just have like a JSON REST interface. Where you can just get the tables from. And also Iceberg is a bit simpler because for Iceberg, you only go to Hive to get like the metadata location. You take this metadata location, go back to the Iceberg library. The Iceberg library will do the rest for you. And we're object stored independent. So S3, Ozone, HDFS, whatever you prefer, you can plug into it. Yeah, it's for Tabler. So that's my company, just a small idea of what we're doing. We're providing like this managed catalog, so you don't have to run it yourself. Services and automation on top of it, so like compaction of the data. Then we provide like access control. So this is the current state of Iceberg. So what's next? What's in the pipeline? So currently the community is working on the multi-table transactions, which is quite a hard problem to solve. So often you don't, with your traditional database, it was very easy to do like a lock on multiple tables, or you could do like something atomically. In a distributed system like an object store in Iceberg, it's a bit harder. So that's what we're working on right now. Scan and commit metrics. It's that's already in there actually. But like I said, with Iceberg, it's very easy to tune your tables. So for example, if you notice that a different access pattern or your tables are not in the right shape, you can get this from these metrics, and then you can also, for example, trigger jobs to optimize your tables there. And the third one is view support, which sounds like we already have views. But as Iceberg is like engine independent, we also want the views to be engine independent. So the view will just like a definition of wanting like different Iceberg tables or potentially also other tables in a single view. And this view can then be read like from Impala, but also from Spark, and it will give the same result. So the view doesn't live in like the inside of the engine, but it's like something that's also on top of the object store. Yeah, like I said, I'm a very big Python enthusiast, so I definitely want to plug like Iceberg in here. So this notebook is also available just to show you like how easy it is just to also interact without like a JVM with Iceberg. So if you install PyIceberg, you get like the PyIceberg binary on your path, and you can say like PyIceberg list, with list like all the schemas. Nope. You say like list inside of New York City, and there's like a New York City taxis table that we just created. Use the CLI, you can also say like PyIceberg describe the table, and then we can see like the table for what version, where the metadata is located, the unique identifier of the table, and the partition spec that we just changed. It's the pickup time with a month function on column 2, which is the column 2 ID here. Iceberg internally we use column ID, so if you change the name, that's all fine. it still points to the same field ID. And the current snapshot is this ID, which has a parent, and there was like a replace operation. And because we actually took all the data, it wrote into like a different partition format. And yeah, and we didn't add any data. We just replaced all the data into a different layout. And then we can see also all the snapshots that we saw. And so these four are the inserts for Parquet files, then added like the column. So we see like a new schema being added or being incremented. Schema version 0, schema version 1. This snapshot was like the replace operation. Also, using Pi Iceberg, it's very easy to look up the data. And so this is the latest snapshot. That's the one that we see here. The manifest list is here, which is like an Avro file. We have the manifest itself, which is also an Avro file that points to these data files, which are all these Parquet files into the different partitions. So if you're ever wondering like, where's my data? Also, Pi Iceberg is a very easy tool just to check this. Also, you can query data with it since a recent version. So let's take the New York City taxis data set. Let's filter on this field, and let's pull it to Pandas. So these are like 9 million rows. And then we have it in a data frame. It's 1.4 gig in memory. And we can look at the data as well. And the idea with Iceberg is that the table itself is huge, but often you take, perhaps for example, for data science or analytics, you take like a slice of it or like a certain a time frame. And then you can filter on it down though. And for example, you want to plot it. You see like it's extremely skewed. Yeah. We're plotting like fair amount here. And we see like someone paid like 400K for cab ride. It doesn't seem right. Like a lot of noise in this data set. And if we say like, some statistical test of, let's remove everything that's 3 times like the standard deviation. And then we get like a better result. Also, you can pull this easily into DuckDB. Oh wait, I have to do this one first. Not the demo track. So it's actually creating like the DuckDB in place inside of Jupyter. We say like the tip amount that we just had as well. Want to bucket it into a histogram. We also see like it's also probably skewed again because I don't think a lot of people pay like $1,000 on tips. And if we filter it again with the same thing, like 3 times the standard deviation, then we get like a nice histogram. And most people pay like $2 for the tips. A question again after a lot of like how to get involved in the open source. The most important thing is start using it. I think most PRs come from people starting using the project, bumping into something and saying, oh, this is not expected. And yeah, they're actually solving it by just creating like a PR. I also created like a YouTube on how to get started very easily with the Python development. And for example, one thing I can see that we need to get in is like Kerberos support, because that's not in there today. So that might be nice PR for someone who's eager just to get their hands dirty. And that's it from my side. I hope you enjoyed the talk. Hope you learned something. Let me know if you have any questions.
Thank you very much, Foucault. Any questions from the room?
Well, one question.
Go ahead.
The order of the attributes when we load a file is not important to the partition column, right?
No. So you can always like repartition later. You can partition it directly, which is probably a bit more efficient, especially if you have like lots of data. Then you directly want to partition it, but you can also just first load it to an Iceberg table and then partition it afterwards.
Okay, thanks.
Oh, it is only small file problem. Iceberg.
Yeah, so in the demo, we did like rewrite data files, and it actually has like a target size. By default, it's, I think, 512 megabytes. So it tries to create like Parquet files that are 512 megabytes. And this is like the new version of the data. So then you can remove, and using the remove orphan files procedure, you can actually remove like the old files, and then you will compact like these many small files, small Parquet files, into a huge 512 megabyte Parquet file. You can also tune this if you prefer bigger or smaller, depending on the type of data. You can also tune this.
Thank you.
Yeah, it is from Zoom. So I have a question. So can we manage the tables using the Pi Iceberg, or we need to use Spark only to manage the table?
Yeah, for the table maintenance, Spark is the best choice. So for example, if you write like to an Iceberg table a lot, your metadata will grow and grow. And at some point you have to clean up your old versions. You don't want to keep like snapshots around for years. So at some point you say like, okay, I want to remove like the old snapshots that are older than 14 days, for example, or like 1 month, or what's applicable for the table. And Spark has the best support to do this. So for Spark, like all the procedures are there. It's very easy to do these maintenance jobs. For querying the data, and there's like a very wide set of tools that you can use, like Impala or whatever. So for reading, yeah, you're very flexible. But for the table maintenance, currently Spark has the best support. It's easiest to use.
Hey, Foko. So I have one question. How good is Iceberg for the streaming kind of use cases?
Yeah, very good question. So for streaming, it's often used like for CDC kind of applications where you have like a stream, for example, like stream of replicate like an operational MySQL database into your data lake, and it's typical CDC kind of situation, or where you, for example, have like an event stream and you want to stream that onto like an Iceberg table. That works very well because you can just accumulate the data into micro batches, and these micro batches can actually be appended to your Iceberg table. The only thing is that you have to do a bit more table maintenance, because if you're appending every 5 minutes, for example, and you create like a snapshot every 5 minutes, you have to make sure that the metadata doesn't grow out of control.
Yeah.
And what you can... Oh, please go ahead.
Sorry to interrupt. So in that case, let's say both table maintenance and streaming both are happening consistently.
Yeah.
Kind of starvation problem arise at some point of time.
Yeah, if you have like a fairly big stream, that could happen, but we've seen this pattern like being used in the industry. Yeah, so it's actually quite battle tested in that sense. Maybe also good to mention, also for the CDC and also for like for example, upserting data, you have like 2 strategies. You have like merge on read, and you have combine on write. So what this means is like merge on read is that it will just like write like the new versions of the rows inside of the Iceberg table, and once you start reading it, you will like do the the deduplication and find like the latest version of the table, which makes like the writes less expensive and the reads more expensive because you have to do the deduplication on the read side, and you have like combine on write. And what it actually means is like if you insert like a newer version for some kind of ID column, then it will like figure out like, okay, is this column already in there? If that's the case, I'll replace like this Parquet file with the newer version that has like the latest version of the data. So you're also flexible in that sense.
Thanks.
So I have a question regarding the merge on read. So basically, let's suppose I have a streaming use case. I'm writing basically a clickstream data to the Iceberg, okay? And while reading the data, you will merge and read, correct? So will it also generate the merge files, or it will just use the existing file, and whenever I have to read, then it will merge at that point and use that?
I didn't really. There's a bit of noise on the line.
Okay, so I'll explain again. Okay. So let's suppose I have a clickstream data. I'm writing it throughout the day. Okay, and I have written some 1 million files.
Yeah.
Okay, and at the end of the day, I have a batch which basically reads the data from clickstream and writes into another table. Basically, it cleans the data and writes into another Iceberg table. Okay, so in this scenario, it will do, and I have enabled the read on merge. So my Spark job will basically read this data. It will have the merge state, but will my files change? Will the merge data will be returned into the source table again or not?
Yeah, there's a lot of ads in it. I should have added like a slide from this. So if you do like read on merge and read, then you will have like data files and delete files. And delete files will say, oh, this row is not valid anymore. It's replaced by a new row. So that's actually happening on the read side. You can also combine this again, that you say like, okay, I want to get rid of all the delete files, and then it will actually optimize the table again. This is very nice. For example, if you append like to a daily partition table, at midnight you will say, okay, I'm gonna like optimize like all the data of yesterday, right? So then the day has passed, no data is being added anymore. There's no action anymore in that single partition. And they will say like, okay, I'm gonna optimize this partition just to make sure that it's performant on read. Does that answer your question?
Yeah.
Thanks.
Any other questions, anyone? There are a few questions in the chat.
So you're talking about the CDC, correct? So does it support the Debizium Kafka CDC method, basically Kafka Connect to Iceberg? Can we have writes from Kafka Connect to Iceberg?
Yeah, right now that's mostly you have like a Flink job that you can use for that. And there's also ideas of building like from the community to build like a Kafka Connect natively. And what it will do, it will have like partition writes. So like all the streams being consumed, and we'll have like multiple writers. And then once this file closes, it will actually emit like the file back to Kafka. And then you have like an Iceberg committer that will actually append like all these files that will be written to the Iceberg table and create like a new snapshot.
Good.
Foco, there's a question in Zoom. He or she hasn't entered their name. The question is, I see DBT Iceberg version 2 PR is open. How's it coming along, and when can we expect it to be merged?
I'm not seeing the question, but thanks for repeating it. Yeah, that's a hot topic. I've been pushing it personally, like on it quite hardly. It's at the DBT the DBT labs just to review it. So there are two possible solutions to this. First is like having the DBT Spark pull request that's now open being merged. Another option is also fixing like this issue, because it's actually a workaround, like a bug in Spark, or like something that's not yet implemented in Spark, I should say. So once that pull request in Spark has been merged, then we should also be able to use Iceberg in DBT. I cannot give any guarantees, but hopefully, the coming weeks would be awesome. Well, I'm thinking on it like on a weekly basis.
Thank you, Foko. And for those who are on Zoom, please share your feedback. I just shared a link there. It'll be great and it will help us do a better job next time. Any improvements, any feedback whatsoever. And those who are in the room, I've put up a QR code on the other screen. It'll be great if you can scan it and give us your feedback. Thank you very much, Foko. Thanks for taking time out of your busy schedule and waking up so early in the morning so you can talk to us.
Happy to. I hope you enjoyed it.
Yeah. And thank you very much. Thanks to everyone for on the Zoom, as well as people here in the room for taking the time to join this meetup. And I guess we'll give back the hour. We are wrapping up an hour early. So thank you very much. Have a good day.